All of our systems leaders agree that system work is teamwork. In systems research endeavors, teams are comprised of members with a broad range of skills and abilities. Building that team, providing leadership and support are keys to successful projects. As Dr. Vivian Allen explains, it takes a team of talent to deal with the complexity of systems research and justify the cost.
So it absolutely mandates a team approach. It's just critical that you look at this from every perspective that you can possibly look to understand, first of all, why that system's behaving the way it's behaving, and again, because all this information is out here waiting to be learned, it's an enormous investment of time and people and space. When you move towards doing systems research, you face a whole different set of issues. One of the first is building a team to work together. Systems research must be approached by a very diverse team of people that want to work together, that can work together well, and can look at these pieces from as many different perspectives as you can bring people to the table.
Building the right team, supporting the team, leading the team are as important as the technical skills of individuals. Of course, the ways teams get organized depends on the individuals involved, their skills and experiences. But still, there are common themes which both Charlie Jackson and Anthony Flacavento have on their list of recommendations in building a systems research team.
Well, I think part of building those teams is that you need the grounding of understanding. You need to be kind of immersed in what you're doing so that you have an understanding of kind of that universe in which you're operating. And then for me, it really is understanding where it's going to be used. What's the application of the research that I'm going to be undertaking?
We had formed a team. We had ASD, and within ASD we had these working teams, and our ag team included everything from beginning farmers, sort of back to the lander types, to traditional tobacco farmers. So we kind of ran the spectrum, and also age-wise. It included educationally oriented groups. Several of those were a piece of it, local and kind of regional groups who they saw as their mission to educate consumers, educate farmers. So we had the education piece of it. We had a few buyers involved. We were starting to talk to supermarkets. We were beginning to work with the Abingdon market. And so just the nature of the team kind of stretched us also to think about all the pieces and parts and how they fit together. I think that it makes sense at times that the leader does drive the train along a little bit and sometimes does a little shoving. The key is you got to know when to do that, and you also need to recognize, another Wendell quote, he says, so often we come with vision but without sight. So I did have vision, but it was a lot of the early challenge for me was to have sight, to see who was in the room, to see the assets of the region, the assets of this group that was giving birth to all this. And so once I realized the strengths we had there, the need to push, the need to kind of be out front was much smaller than I thought it would be.
Building the team takes leadership. It takes work and focus. Leadership does not just happen. It is an intentional component of successful systems research. Effective leaders bring specific skills to the project. Here is Paul Mueller's approach.
And we have several disciplines involved: soil science, entomology, plant pathology, ag and resource economics, animal science, crop science, and several others. So I'm representing probably a dozen or more different scientists from 10 different departments in our college. And it's critical that they stay engaged and interested, and you're able to coordinate those efforts. You have to have a group of people from different disciplines that have more or less a common goal and understanding of what you're about to do. And you know, it's a real challenge because there's a lot of distractions from this at the university in many ways, and maybe distraction isn't the best word to use, but every scientist has multiple goals and multiple demands on their time. So keeping a solid group engaged in this team effort is a challenge.
And Vivian Allen's thinking about leadership is similar. She also suggests that a breadth of skills need to be integrated into the team and its leaders.
Qualities that are necessary for the leader of an interdisciplinary project are probably varied, but I think it must be someone who likes to look at the big picture, but has some knowledge at least to be able to be conversant with a diversity of the pieces. You bring a team together because they are the specialists in all the different areas, but that leader has to be able to work with that team and has to keep the effort organized. You have to be able to communicate. You have to be able to keep data available and organized and working with a lot of different people, a lot of different kinds of data. You have to be able to talk to the public about what's going on. You have to be a fundraiser. You have to be a lot of different things. It becomes, in some sense, more of an administrative job than the researcher itself. But that person, most of all, has to be able to work with people. They've got to understand the need for systems research. They've got to be able to communicate that need, and they've got to be able to help to keep that team together and working together as a well-functioning team. And that changes over time. You have to be adaptable. So there are a lot of things that you need in that person that's going to lead that effort. At the same time, you have to understand that it is a team, and that person is part of that team. And so it's not a leader and a follower situation. It's a we're in this together situation. And we work together to find these answers. So a lot of things come from a lot of the parts of that team to make this whole thing work.
We don't want to suggest that scientists from specialties should not be leaders, but we do suggest that leaders of systems research teams must think beyond one discipline. So, ecologists and some types of economists may be natural fits, which is what Dr. Allen suggests.
I think leaders of interdisciplinary research are likely to come from some disciplines more than others. I think some disciplines, and I'll use my own example of forages. If you are trained in forages, you must know soils. You must know animals that are going to graze those forages or consume those forages. You must know something about climate and natural resources, and you must know a pretty broad amount of information if you're going to work with this array of plants we call forages. And I think that is very helpful if you're going to be involved in interdisciplinary research and systems type research, as opposed to someone that's very narrowly trained. An example might be someone who's trained in basic chemistry, who works very independently on some very basic question. I think they're less likely to want to be involved in this type of research. So yes, I think some disciplines do lead themselves more than others to prepare you to be able to work within that systems context. But part of the ability of that leader has got to be the ability to bring those people together that are both narrowly trained and broadly trained, and put them together into a very well-functioning group of people that do work well together.
Even though that has been Dr. Allen's model, there are examples of scientists from more narrowly focused areas delivering good leadership. But they may come from a leader's personality instead of her or his scientific training.